Hello again. My name is Jim Bradley, and I am the faculty sponsor of the College of DuPage Math Club. Today, we're going to have a talk about mathematics, which is a COD Math Club work product, and this talk was given in December of 2021. I shared this with my discrete math class, and so these comments are preamble to Jesse's talk, but primarily for my discrete math class. So things to notice during Jesse's presentation. Mathematicians make conjectures and then try to prove them. Jesse's conjecture was first proposed by Paul Erdős and a collaborator. And as my colleague Jim Meducci says, many Erdős conjectures are out there. Paul Erdős was an influential Hungarian mathematician who in the later part of his life spent a great deal of time writing papers with a large number of collaborators. This is a picture of Paul Erdős. He wrote more papers than anybody else, over 1,500, although Euler published more pages of mathematics, but there were fewer papers, about 800. And he had over 500 collaborators around the world. And he spent his time traveling and working with the collaborators. He was a caregiver for his mother, and so she often traveled with him. The idea of an Erdős number was originally created by mathematician friends as a tribute to his output. Later it gained prominence as a tool to study how mathematicians cooperate to find answers to unsolved problems. And there are several problems that use an Erdős number as a proxy, and they tell how authors cluster and how the number of authors evolves or as new theories propagate. Several studies have shown that the leading mathematicians tend to have particularly low Erdős numbers. The mean Erdős number of a field medalist, the highest honor you can win in mathematics, is 3. Only a little over 7,000 have an Erdős number of 2 or lower. As time passes, the smallest Erdős number can be achieved will necessarily increase because mathematicians with low Erdős numbers die, and that means they become unavailable for collaboration. Still, historical figures have low Erdős numbers. For example, the renowned Indian mathematician Ramanujan, and this was a book about his biography that I would recommend, The Man Who Knew Infinity, has an Erdős number of 3 through his mentor, Hardy, who wrote A Mathematician's Apology, also a very worthwhile reading, even though Erdős was only 7 when Ramanujan died. There is a biography of Erdős that I've recommended to some of my students. The title of this is The Man Who Loved Only Numbers. One of my students, a young woman, told me she thought that was very sad, that he loved only numbers. I told her she didn't appreciate how deep the love story really was. Another thing to notice during the presentation is progress is sometimes achieved a step at a time through special cases. The great mathematician Sophie Maine contributed to Fermat's last theorem, particularly for n equal 5. And Sophie Maine is an interesting story among her to herself as well. She began corresponding with the great mathematician Gauss, but she had to disguise her name, so she wrote to him and signed it like she was a man named Monsieur Leblanc. Gauss was eventually thrilled to find that his pen pal was a very gifted woman. She proved that if x, y, and z are integers, and if x to the 5th plus y to the 5th equals z to the 5th, then either x, y, or z must be divisible by 5. That was a major step towards proving Fermat's last theorem for the case where n equals 5, and the general theorem, which was proved and described in this excellent book as well, Pierre Fermat's last theorem, was not proved until the late 1990s, and what it says is that if x, y, and z and n are integers, then x to the n plus y to the n equals z to the n can be solved for any integer greater than 2. Another thing to notice from Jesse's presentation is that collaboration is very much the norm, not only in Erdős, but with others. Papers are written jointly frequently, and increasingly this happens across diverse mathematical fields. There are Erdős numbers, and Jesse has an opportunity to earn an Erdős number. He studied with a person who has an Erdős number, and they may someday collaborate. And you can see that Jesse, in fact, collaborated on the paper he's talking about with Jack Witt. Another point, the problem need not be motivated by an application, but that does not mean that today's abstract mathematics will not become tomorrow's applied mathematics. This is Lobachevsky, who developed hyperbolic geometry, which proves that Euclid's fifth postulate is interchangeable with other postulates and still have consistent geometry. And he was also a rector of a great Russian university. And in fact, the exact quote is, "There is no branch of mathematics, however abstract, which may not be someday applied to the phenomenon of the real world." A final note is that precise definitions are crucial, and we build upon the theorems of others. But the general proof techniques are the same ones that we've studied in our class. You will see that Jesse and Jack's main result is proved by the method of contradiction. And please be aware that AMATIC also sponsors undergraduate research, such as Jesse's sharing with you, and so there are opportunities there. And as you can see, there's many definitions and concepts in Jesse's abstract. Now we'll move on to the main event. I'm introducing Jesse Hayes Carver. This is what he looks like, and he's being embraced by a friend here, and probably that friend is a student. Jesse is a COD Learning Commons tutoring living legend. He's a remarkable young man. He's fluent in Japanese and martial arts. He's an aficionado of high-performance cars. He fosters collies. That means he has a soul. And he is a passionate mathematician who began in developmental math and, in my estimation, has no ceiling. My colleague and my friend, Jesse. Please take it away, Jesse.